Hello everyone, welcome to yet another video series of measurement and instrumentation. So in last video I have given an introduction about AC potentiometers, what are its type and why it is named as polar type potentiometer and coordinate type potentiometers. So in this class we will be discussing in detail about polar type potentiometers. So here in polar type potentiometers we have two different set of windings which are called as stator windings, and we have a rotor winding which is calibrated in a which has a dial. So the supply is given AC supply, and we have the stator windings. Both the stator windings are kept 90 degrees apart. So one stator winding is connected in parallel with the supply, and the other one is connected 90 degrees apart because it has to provide the same voltage but with a 90-degree phase shift. And this 90-degree phase shift is achieved by adjusting the R and C, variable resistor and variable capacitor, connected in series with the another one stator circuit. And the test circuit is being connected to the potentiometer, and also the supply from connections from rotor will also be connected to the potentiometers. So a polar type AC potentiometer will consist of a DC potentiometer which measures the magnitude alone. Then what about the phase angle? To measure the phase angle, we have a dialed rotor winding, wherein which the dial will show the angle deflection. So when the AC is being supplied, when the AC supply is being given, the stator winding will get energized and a flux will be induced. Since we have two phase stator windings which are at 90 degrees shift, an EMF is induced. The fluxes which are produced in the stator windings will produce an induced EMF in the rotor windings. We have two stator windings, so two fluxes will be produced, and these two fluxes will be with a phase shift of 90 degree, because which we adjusted the phase shift by adjusting the R and C. Therefore the current I1 in the stator winding will be I1 at an angle of 90 degree in stator winding 2. So now the rotor will move because of this rotating flux in the stator windings. The movement of rotor winding will decide the phase angle of the AC supply. So this movement is proportional to the phase angle. How much it moves can be measured from the dial attached to the rotor winding, and the magnitude of the supply of the unknown voltage can be measured from the potentiometers. So here I have given the explanation for the circuit. So in polar type instruments, two separate scales are used for measuring the magnitude and phase angle. So one scale will measure the magnitude and the other scale will measure the phase angle. So how it measures? It compares with the reference EMF. So there is a provision on the scale that it could read phase angle up to 360 degrees. So we have seen a dial now above the rotor. So it has 360 degree scale. So how much the rotor moves can be easily identified from the scale. And it has an electrodynamometer type ammeter along with a DC potentiometer and a phase shifting transformer, because the AC supply cannot be given directly to a potentiometer. So the 230 volt AC supply is being stepped down to 6 volts. and it is being fed to the potentiometers. So it is operated by a single phase supply. So between the stators there is laminated rotor having slots, and it is connected to the, and this rotor supplies an EMF is induced in this rotor, no, so that EMF induced is being connected to the slide wire circuit of the potentiometers. So how much EMF induced in the rotor will be measured with the potentiometer, slide wire potentiometer, and how much shift is in the supply is can be measured from the rotor movement. When the current flowing starts to flow from the stator, the rotating field is developed and the rotor induced EMF. The phase displacement of the rotor EMF is equal to the rotor movement angle. So the whole arrangement of the winding is done in such a way that the magnitude of the induced EMF in the rotor may change, but it does not affect the phase angle, and it cannot be read on, and it can be read on the scale fixed on the top of the rotor. So this is the working of an polar type potentiometer. So from the circuit it is very clearly visible the circuit connection to the potentiometer from the rotor is used for energizing the potentiometer, and it is the input to the potentiometer, that is the unknown EMF from the rotor is measured by the potentiometers, and the unknown phase angle is measured by the position of the potential rotor which has a dial above it. So this is the construction and working of a polar type AC potentiometer. In the next class we will discuss the other type, which is the coordinate type. So stay tuned and have happy learning. Thank you.